is that?
256 over 25.
And do you know how to turn that into a decimal?
No.
You press the SD button and next one, 5.9 squared.
$34.81.
34.81. Well done. Let's try cubed. 2.7 to the power of 3. And so you just put in 2.7 first, then you press that empty box one and you put 3 in the box.
So I've got 19.683.
19.683. And then how about the last one? 10 to the 5. Same idea.
Um, 100,000.
That's it. And 5 zeros. Okay, any questions there?
No.
Okay. So 100,000. Okay. 21 to the 3. I think you'll be okay. Try this one with the fraction. Any idea how you do the fraction one? 1 over 2.5 cubed.
No, let me see.
So for that,
1.
you see under the add,
It's 8 over 125.
and it says you must give your answer as a decimal.
Okay, do I press that SD button?
That's right, yeah.
So, 0.64.
How many zeros is it?
0.0642.
That's it. Okay. How about the next one? See if you can find the square root one.
$12.9786. Okay, SD. Oh yeah.
And try the very, let me just try 12.9786. Well done. Now try the very last one. So that's the square root of 14.44, and then times that. And you'll have to use brackets for the second part.
Um, 1843 over 100.
And it wants as a decimal.
18.43.
And is that all the numbers?
Yeah,
Okay.
that's what came up.
Okay. Any questions about anything there?
No.
Okay. Okay, these are still calculator. Let's try these first two separately. So how can you do this first one?
So that's 0.7 plus 1 squared over 2x over 2, so 2.7.
2x is short for 2 times x.
Okay, so 2 times 0.7. Give me my maths. Okay. 0.7 7 plus 1 squared over 2 times 0.7. 289 over 140.
And as a decimal?
Let's do 2.0642.
Okay. How about the one above it?
For one above it. Y equals x squared. X squared. Minus 25.
And so, what does squared mean?
Times it by itself.
And so, what is minus 5 times minus 5?
Minus 5 times minus 5. 0.
Times minus 5. Minus 5
Minus
times minus 5.
25.
And so,
And that's because they're both minuses. Two minuses make a plus.
that's right. So what the calculator did the first time was it did BIDMAS. It did minus 5 squared. And it said, well, it did the index first. And so that was 25. And then it does the minus last. And so it says it's minus 25. For this one, when you're substituting in a negative number, you need to put it in a bracket. So try putting it in a bracket this time. Minus 5 with the squared outside.
$25.
That's it. And so we know the right answer is 25 because minus 5 times minus 5 is 25. And so, yeah, when you sub in a negative number, put it in a bracket. Otherwise, the calculator will do BIDMAS and say it's a negative number.
Yeah.
Any questions there?
No.
Okay. Then we have this one. I think you'll probably be fine. Oh, we might as well do it. It's a tricky one. Okay, how about this one here?
That. $50. How would I do that? That'd be 50.
Yeah.
Okay. 20.284.
20.284. And they want it to one decimal place. Any idea what that would be?
Do I press SD again?
No, you would just have to round it yourself. 20.284 to one decimal place.
20.
So that would be to no decimal places. You need one number after the decimal.
20.2.
And is this number closer to 20.2 or 20.3?
20.3.
Yeah. And so that's, we rounded to the closest one.
Yeah.
Any questions there?
No.
Okay. Okay, this time, so it's non-calculator. How would we do a question like this without the calculator, do you think? Because I don't know.
We would solve for 5. times 5 times 5 times 5.
So I don't know what that would be without a calculator, and this is non-calculator. So basically 1, 2, 3, 4, 5, 6. So there's 7 5s on the top. There's 3 5s on the bottom. We can work in reverse and separate these out in the same way. If you had 2 over 3 times 5 over 7 or something, you can bring the two together. And obviously if you can bring them together, you can bring it back to the original question. You could just separate them again. So you can do the same here. So you can say that's 5 over 5 times 5 over 5 times 5 over 5, and then we've just got the 4 5s left over. What is 5 divided by 5?
5 divided by 5 is 1.
And so you've got 1, 1, 1. And what is the short way of writing 5 times itself 4 times?
5 times itself 4 times.
Yeah, in index form, what would that be?
5 to the power of 4.
Yeah. And what is 5 to the power 4 times 1?
20.
That's 5 times 4. Just 5 to the power 4. What is any number times by 1?
1. Or whatever.
Yeah, it's itself. And so it's just 5 to the 4. What would be the quick way of going from having 7 and 3 to 4?
Having what, 7 to 3 to 4. 7 to the power of 3 times 4.
Well, you need to do something to 7 and 3 to make 4. So what would go in the middle?
Please say that again, Dara.
So what operation would you do to 7 and 3 to turn them into 4? Like 7 plus 3, 7 times 3?
Divide it.
Does 7 divided by 3 give you 4?
No. Oh, subtract it.
Correct. So the quick way to do these is you copy the base and you subtract the powers. So 5 to the 7 divided by 5 to the 3 is the same as 5 to the 7 subtract 3. And so it's just 5 to the 4. And that's always going to be the case, because however many are on the bottom, you're always going to delete that many from the top, because it's basically times 1, which is just itself. So the quick way of doing these, copy the base, subtract the powers. So let's try, let's start with this one. What would that be?
For the first one, would it be I don't know how you do that. Would it be?
Let's try this one down here, the 7.
Okay. 7 to the power of 8.
So the quick way to do these, so you could write, 8 7s on the top and then 3 7s on the bottom and cancel them out, cancel out the 3 and count whoever is left. But in general, it's just going to be, you copy the base, so 5, and subtract the powers. 7 take away 3 gives you 4. So 7 to the 8 divided by 7 to the 3.
7 to the 8 divided by 3. So 8 and a 3 bit, would that be 2?
No, so you copy the base, and so what is the base?
7.
Yeah, and you subtract the powers. So 8 take
5.
3. Correct. So it's 7 to the 5. That's all it is. There are going to be 8 sevens on the top, 3 sevens on the bottom, and so if you take those 3 away, because they're going to cancel out the ones on the top, you get 7, 6, 5, and so you'll be left with 5 sevens in total.
Okay.
Let's try the M one. M to the 5. And these letters just stand for numbers.
Okay. Would it be M2?
Well done. How about the next one?
Y2?
Next one. And
X,
over. Sorry, go on.
X4?
Yeah. Over is just another way of saying divided by. That's it. You've got it. Any questions there?
No.
Okay. How about this one?
A1?
That's right. So that's A1. And if you were to do it the long way, you'd have 3 A's on the top, 2 A's on the bottom. A divided by A will be 1. A divided by A will be 1. You'll be left with 1 times A, which is just A. And what that shows you is that A to the power of 1 is the same as A. And so basically, if you see any number by itself, that means it's that number to the power of 1. So if a number doesn't have a power, it means it's to the power of 1.
Okay.
So what is X to the power of?
1.
Yeah, so X is the same as X to the power of 1. How would we do, what would this one be?
The first one might be N5,
Okay.
then T5, then N2.
Correct. And you're okay there. Yeah, because it's the power of 1. Okay, write this as a power of 10.
10 to the power of 5.
Yeah. How about this one?
Ten to the power of 7.
How about this one?
P to the power of 4.
Well done. I'm just going to skip these questions because I think you'll be able to do them. Any idea how we could do a question like this non-calculator?
Two, 1.
So that would be if it was divided by. This time it's times. And so if we were to write this out the long way, 2 to the 5 means 2 times itself 5 times. 2 to the 6 is 2 times itself 6 times. They're times each other. And so how many times is 2 times itself in total?
11.
And so how could you write that as 2 to the power of something?
2 to the power of 11.
That's it. What is the quick way of going from having 5 and 6 to 11?
Sorry, what?
So what's the quick way of going from having 5 and 6 in the question to 11 in the answer?
Adding up.
Correct. And so the rule for dividing index numbers was you copy the base and subtract the powers. What do you think the rule is for multiplying indices?
I don't know. What was it again? Rule for dividing indices.
It was copy the base and subtract the powers. And so for multiplying indices?
Copy the base and add the powers.
Correct. Yeah, 5 plus 6 gives you 11. So that would have worked. Okay, what would this be?
P to the power 5.
Correct. And if you wrote it the long way, there'd be 3 p's, there'd be 2 p's, it has a times in the middle, and so in total 1, 2, 3, 4 p to the 5. How about this one?
And 6.
That's it. And do this last one.
X9.
That's it. Okay, so we're fine for that. That. Okay, any idea about this one? Sorry?
6x9.
Perfect. Got it for a shot. Let's try this one.
What is that? I don't know.
So if I wrote it the long way, it'd be 3 times s squared times t cubed times 4 squared times s to the 4 times t to the 2. You know how 2 times 3 times 4 is the same as 4 times 3 times 2?
Mm-hmm.
So I can move these around. So I can put the numbers next to each other. I'll put the s's next to each other. And I'll put the t's next to each other.
Okay.
But it's the same thing. So how about the first bit?
12.
Yeah. Second bit?
S6.
And last bit.
T5.
And the short way of writing these is without the times signs. And so what's the final answer?
12 S6 T5.
That's it. And if you go back to the original one, you don't have to always write it out the long way. You can just do number times number, s times s, t times t. And so that's 12, that's s6, that's t to 5. Any questions there?
No.
Okay. Let's try, I think there's, yeah. Let's try this one.
Six W 7 X3.
Perfect. Absolutely perfect. How about this one?
5x6 y4.
Got it. And I think you're, oh, let's try this one.
21w5x2.
It's not W5.
Oh, sorry, w4x3.
And X3. That's it. So that one had 2 things. Any idea how you'd do this without a calculator?
Eighteen
Yeah, and then times.
times 10 to the power 6.
That's it. And you could leave it like that. That's fine. These questions, I think you'll be okay. Okay. What would be this one here?
Six.
Correct. N equals 6. Oh yeah. Okay, let's try And I recommend you just do the top first and then, yeah.
Would it be N10?
So N10 on the top. So what is the final answer?
N16?
That would be if it was N10 times N6. This is N10 divided by N6.
Oh. N1?
What's the rule for dividing index numbers?
Oh, yeah. Can't remember, don't you?
Or if you do it the long way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ends on the top. 1, 2, 3, 4, 5, 6. 6 ends on the bottom.
Oh, 4N.
That's it. And so,
So it's subtracting.
sorry?
So it's basically subtraction.
Yeah. And so what's the final answer?
N to the power 4.
Correct. That's it. Okay. Let me just check something. That one is. Let's try this one.
So that's 7 to the power 5 over 7 to the power 1.
Mm-hmm.
7 to the power 4.
Well done. Got a first shot. Let's try this one.
Q to the power of 8 over Q to the power of 2.
Mm-hmm.
We come out Q to the power of 6.
Yeah. Okay, let's try this one. And you might find it easier if I wrote it as a fraction, but it means the exact same thing.
Over to the power of 1, 2. So that'd be A to the power of 5, or
So
that'd be 9 A3.
So it's a to the 3, and then normal numbers just work normally. So 12 divided by 3?
4.
That's right. 4. And so the quick way is just number divided by number, same letter divided by same letter. How about this one?
15. So would that be 5 A1 B4?
Yeah, and I'll just leave it without the 1, but you get full marks if you put
Yeah.
the 1. Maybe I'll just write that. 5 A1 B4 is also correct. That one I think. Okay, I'll do this.
Six Q9 over Q3. 6 Q6.
Correct. 6q to the 6. And then this next thing is a different thing, which I would do. Oh, I'll do it now. No, I won't. I'll go back to the beginning. Yeah, so we looked at BIDMAS, the order of operations. You had to do indices first and then add the 6 after. So we did these squared, cubed, power 4, non-calculator. So 3 to the 4 means 3 times 3 times 3 times 3. What would be the square of 5?
25.
Yeah, 25. How do you know if a number is a square number? What does that mean? It's a square number.
Ends in a 5.
Well, 9 is a square number, but that doesn't end in a 5.
Oh. Um,
How do you get the square numbers?
I can't remember. Isn't it something to do with multiplication or?
Yeah, it's literally just 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and so on.
Yeah.
And your answer, they're called the square numbers. How would you get the cube numbers?
Um, I don't know. Would it be? I honestly can't remember.
What does this one mean? The cube of 3.
It's 3 times.
Yeah, so 3 cubed or 3 to the power 3. And so to get the cube numbers, any idea how to do that?
Got to times it by 3.
You to the power of 3.
Oh, okay.
Yeah. And so you do 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, and so on. And those give you the cube numbers. And 5 cubed was 125, and so the cube number in this list was 125. That's what that means. So we did these, looking at bidness. And I said we should do bidness next time. Okay, so we used a calculator. How do you get squared on your calculator?
Press the little X2 button.
And then how do you do to the power of 5?
You get that little X with a little white box and you type number 5 in.
That's it. And so we did the square root, we did that. Brackets. How do you sub in a negative number?
I don't know.
In a bracket. So
Okay.
you don't do minus 5 squared, you do in a bracket minus 5 and that whole thing squared.
Okay.
So it does minus 5 times minus 5 instead of 5 times 5 and then taking it away. So you did that substitution with squared. Okay. Let me just go to a question that I skipped and we can do it now. What would be this first one up here? P to the 8 over P to the 2.
P to the 6.
Yeah, so copy the base, subtract the powers, dividing. Here we saw y, any number by itself is the same as to the power of 1. It's like divided by 1, same thing. These were divided. And let me skip to one we didn't do. Oh, we did all of these, did we? No, I don't think we did. Surely I left some. Yes. What is this one up here?
N8.
Yeah. And what is this one here?
P to the power 3.
That's it. And if you think about it, that's P to the 1, P to the 1, P to the 1, 1, 1, 1, 1 plus 1 plus 1. 3. And I left this one. Let's try this one now.
So that's P7, P5.
Well done. And this one. How about this one?
Just the last one.
Yeah. Why are we out of time?
Yeah.
Okay.
So let's
Oh
see
no,
if I
we,
can do
we,
this.
we did this one, sorry. We did that one. So we're okay.
Yeah.
Yeah. How did you find that, Dylan?
Alright.
Yeah, so you're doing great. We did lots of indices simplifying. So I think next time we'll do number like bidmas or something. How does that sound?
That sounds okay.
Okay. Any questions for me in general?
No.
Okay. Well done, Dylan. You're doing really great. And yeah, look forward to talking to you again next time. All right. Have a
Bye.
good one. Goodbye.
Bye. Oh yeah, I'm not here next week as well, by the way.
Oh yeah, yeah. No, I took